Well, very good morning to students. Today we are going to learn a topic of the pressure arch theory, part of the rock mechanics and strata control, which mine supports uh, the pressure arch theory particularly. It is a basic idea to giving to the how the bed separations in board and pillar and all. Based on that one, zones are here divided for determination of support design. First, behavior of the opening that is explained by the different theories. That one of them theory is a fracture arch theory. This is the view of the underground mine. This is the area gateway view of the typical long wall panel get during the retreating of the area. How the rock is distributed and disturbing the surface area showing here. But for the sake of to know the generally, as per the, it is important to clearly understand the behavior of the strata and the associated mechanics in and around the long panel, so that appropriate measures can be applied to control the phenomena. The abutment pressure in the primary conditions, the coal seam can be considered to be a sand, which between the relatively stronger roof and floor rocks, which are loaded by the weight of the overburden. Stress are uniformly distributed in the core seam under such conditions. In a longwall mining, when the coal is extracted, the roof over the gouge tends to deflect at first as the beam support at the two ends. Subsequently, when the critical span is reached, it acts as a cantilever and will be eventually collapses. As a result, stress continuation in the conditions in the panel under extraction get the adjustable until the new equilibrium is achieved. So once the disturbance in equilibrium, the redistribution of the stresses in around the vertical apartment, that is from the vertical and horizontal redistribution is happening. Occur solid cone in front of the long wall face called the front apartment, pressure at both ends, face and along the rib of the gate roads or the side apartment, and the rear apartment is located in the cough area between two gates roads. The sides and front apartment intersect at the junctions of the face, and gate roads are superimposed to become the peak apartment pressures. Depending on the local condition, the front apartment it's first felt as a far. Uh, the increasing pressure distance, and then this is a overburden key strata soft rock. The view of he can observe here the how coal once the excavation is happened, how to the immediate roof is affected over the main roofs how is falling, and also soft rock how they falling, the key strata and the overburden. So entire the hierarchical affecting shown in here. This is a new idea from the stratigraphic sequence in model. The design of effective supports the long bar is but there is still no uniform method for estimate supports. Complexity involved, violated methods are generally applied. The general practice is that if the supports are lower capacity to the next the next one higher capacity that is an appropriate support system must comprehend geotechnical characters of the long run locally to be able to estimate the supports requirement of the place. For effective strata control, the massive and sandstone, sandstone in Indian growth measures, the apprehension about their capability and above all the non-availability of engineers manufactured supports of adequate capacity has already the anticipated growth in the long run considerable extent. The key question remains, however, in the strategy of support and the future long run, so that the one should be choosing individual blocks or going for the power supports. The advantage of power supports are undisturbed, but they are very expensive. The cost of 100 meters. Long wall face powered supports, but mechanized pole winning to get the around sections of human support systems. The estimation supports load requirement and methods are used. So overburden moment in long wall mining. So long wall panel studies in the present in located in the publication of Meter strips, where the most of core seams are shallow, the depth. The overburden strata are mostly wet rock. The panel width can reach up to 435 meters. So when a long wall panel is sufficient width and the length is excavated, the roof is fractured and the convergence between the roof and floor occur at a much greater distance in advance of the faces. The maximum rate of convergence is noticed at about 5 to 20 meters from the face. So overburden movement in long wall mining. Overburden can be generally divided into four zones: caved zone, fractured zone, detailed zone or continuous deformation zone, surface extension zones. These are the zones based on overburden movement of long wall mining. So caved zone and fractured zone, continuous deformation zone and surface extension zones. These four zones are the long wall when the with redistribution of stresses in around the opening. This is overburden moment above a long wall panel. This is the extension zone surface cracks. Once open is happening, it is a zones. This is the cave zone. It's a fracture zone. This is a deformation zone and soil zone. So when the opening, long wall overburden movement in the long wall, this is a highly distributed area because most cracks are happening. And further the above that zone is the fractured zone and also deformation zone. This extension zone surface. This is the length is of the depth of the below 50 meters. So some that will be cracks will be extend to surface also. That is called substrates. You can easily observe the by the seeing the figure. This is a character curve of the convergence in a long wall phase. The character curve of the convergence of long wall with recorded immediately behind the cutter track. So this is the hours and how reduction is the height, cut commencing, cut completed, top that was. So this is the character curve of the curve. And rock property is one of the important parameters affecting the overburden strata movement in this study. Rock samples were collected from the borehole that were located near the gate road, the panel of the interest. So topsoil, the thickness is here. Compressive strength of the particular volume force is here. And also uh, sandstone, fine sandstone, thickness is given, compressive strength and the tensile strength also given, velocity modulus, the volume of the force, primary key strata. Next, middle strata, there is a 14 in thickness. There is no data is available. The fine sandstone 19.45. Compressive strength is 70 megapascal and 10 tensile strength. 5 elastic module GPA gigapascals. 26 the volume of force. Number 2 inferior key strata. Middle strata 52 and also medium of sandstone 10.18.02. 1910 627. Still sandstone coal seams. So this is actually the borehole data based on the for calculation of RMR for helpful. Abutment pressure. When an opening is created in a coal seam, when an opening is created in a coal seam, the stress that was present before the opening was created is redistributed to the adjusted coal pillars that are left. the area within the remaining pole where the vertical stress is greater than the average area, average are called the abutment, and hence the stress in those areas are called abutment pressures. So this is a one of the important pressure where the abutment pressure is active. When the opening is created in a portion, the stress that was present before an opening was created redistributed adjacent pole pillars. So once equilibrium is distributed, the horizontal force vertical redistributed to the in around that particular opening. The areas within the remaining pole where the vertical stress is greater than the average called the abutment, where the remaining pole where the vertical stress is greater than the average, and hence the stress in those areas are called abutment pressures. So abutment pressure in and around the panel, isometric view is given. So wasted area, side strata, pressure abutment, front strata pressure abutment, advanced of pole faces, strata loading pressure, re-establishment in waste area, corner crack, pressure due to the interaction of the front and side apartments. So this is our overall view of the front apartment pressure and around the panel. And front apartment pressure, the bed which become uh, detached from the bed above are relieved of the weight of the uh, height, the strata, and the load, which was originally acted vertically over the excavation area, then deflected uh, and bridge over the working area or transmitted is a weight forward to some region ahead of the code faces of known as a front apartment pressure. This is the exact definition of the front apartment. A bed which become the detached from the beds are relieved from the weight of the higher strata and the load which was originally acting vertically over the excavated area, then deflected and bridged over the working area and transmits its weight forward to some region head of the coal face known as the front apartment. Depending on the local conditions, the front apartment pressure can first be detected at the distance of one of to one time overburden depth out by the face. When the face approaches to within the 30 meters, it's began to increase rapidly. It's reached the maximum value ranging from 0.5 to 6 times the overburden pressure when the face is 1 to 6 meters in height. After the pressure drop drastically, the van and vanish at the face time. Front abutment loads 1.8 to 880 times the overburden pressure have been observed over the 10 to 13 meters wide strip parallel to the extraction front. This over pressure may manifest itself up to the even 60 meters from the extraction front. So the front abutment pressures can about that one. So it is a front and back abutment pressure very clearly given, a particular long wall movement. So critical vertical stress abutment and low stress stretch adapter drop, rear abutment, and primitive vertical stresses, boof and caving, pre-fracture core and virgin core, caving height and cutting. Then front and back apartments, it's when the progressive going on the exposed area, how the behaving of the front apartment movement is very clearly given in this picture. This is a area, this is area when the normal generalized area once open, distribution of back apartment and front apartment, and it's widening going on. It's widening going on. Side apartment pressure. The growth of the side apartment pressure resembles that of the front apartment pressure. The maximum side apartment pressure ranging from 0.4 to 3.5 times. The overburden weight occurs in the first pillar near the go edge. To increase exponentially away from the go edge, the width of the side apartment pressure zone can be approximately by 9.3 root of h. The h is the seam depth. The convergence is generally less than the 50 to 75 mm before the face moving. Rear back and apartment. So the beds which become the detached from the beds above are relieved from the weight of the higher strata, and the load which was originally acted vertically over the excavated area, the deflected and bridge over the working area and transmit its weight forward to some region backward behind the coal face, a region where they again make contact by the substance of the higher bed known as the back abutment pressure. It's located in the Gulf area, bridging between the main gate, tailgate road in this abutment pressure. The maximum pressure which felt in the above overburden pressure. So this is one picture is given clearly. The abutment pressure at the long wall face, the back apartment, front apartment, side of just apartment. Relaxed arch core, front abutment, location of the back abutment, the normal pressure, front abutment, bed separation. Bed separation cavities and excavation made in coal seam. The bed separation activity as the excavation made in coal seam. The roof bed above the excavation tends to curve into the opening, and because of the different curvature, loose contact uh, or separate from the beds above, creating activities between the adjustment beds. Roof beds bends downwards from the over the solid core across the working area. Backfilling material. If you given this is a overview of the underground. This is the backfilling area. So how the different layers to the surface affected area. This is a subsidized area. The surface, water intrusions, bed zone, fracture zone, caving zone, spontaneous combustions, both areas, very clearly showing how the surface is affecting the, bed separations. A certain amount of separation is inevitable when the nature support is removed. It is essential that must be controlled by a close and rigid supports as a uncontrolled movement by giving rise to the dynamic peak load in some parts. The cavity will also act as a reservoir of gases, dangerous suckers. The concept, immediate roof and main roof, the, the total load coming on the support in long wall working. It's a static load, dynamic load. A static load, it is a dead weight of the immediate roof rock. The height of immediate roof is given by uh, the value is given here. This is a how the immediate roof is effective from the surface to here will be explainable easily. Immediate roof and the main roof, how effective the empirical formula here. The caving characters, depending upon the caving character of the roof, rocks are most important parameter of rock behavior, which success of long wall depends. The ideal conditions for strata control in a long wall would be when one condition is a working place is secured by the support system, which offer a resistance enough to the prevent the degradation of the roof, falls, cracking, block areas within the working zone. Overlying roof rocks fall in the roof as soon as the last row of supports are withdrawn and filling the roof completely. While the first condition is sought to be fulfilled by the proposing supports density, such as a limit convergence to the tolerable level. The second is attempted by offering high enough resistance at the roof edge to induce a systematic caving. Uh, it is the objective of this note of the forecasting caving behavior of the roof rock from the laboratory determination of their properties and suggestion measures to show that the ideal for successful long wall become the feasible. It is obvious that the completely fill the roof behind the last row of support, that the thickness of the roof strata should be involved in the caving process, which when the broken and compressed with the weight of the overlying overburden will occupy the volume of the extracted height of the core. Logically, the thickness of strata of the immediate roof is involved. Generalized formula we are using the thickness of cutting equal to h by here is h is given by k minus 1. K is the factor of the bulking factor. So according to that one, you can be height of the extraction multiplied by k minus 1 equal to thickness of that particular immediate proof thickness can be calculated. The bulk factor, when the k factor will be varying, um, k factor will be varying um, easily determinable in the laboratory, but measuring the relatively volume of various material before the after crushing, we found that the broken rock occupied 60% more space than the unbroken, but pressure equivalent to the strata compressed will leave the volume about 12% larger than the original. But, bulking factor of the which is one useful taking in India, thickness of overlying rope that should be involved in the casing. We have to be 5 times the height of the extraction for a completely filling of the rope area. Most of the mechanics, some mechanics of the roof caving is also in test. Uh, there will be different theories also there. So this is the generalized formula. What is H is equal to M minus D, that is the height of extraction minus max allowable convergence. K is the swelling factor or bulk factor. So from this formula also, sometimes the tick TH H equal to height of the immediate roof can be calculated by that is a T, the M minus T, the height of extraction um, maximum allowable convergency. So that is divided by K minus 1. This formula can be utilized for the purpose of the calculation height of the immediate roof. So theory of rock pressures and strata movement. There is a number of theories are there for rock pressure, pressure arch theory. Beam and or plate theory is there. That is a famous theory. Plate movement theory on arch pressure arch theory. Most of the using pressure arch theory. Beam or plate theories and plate movement theories and pressure arch theories. So this is a very uniform, standardized pressure arch theory explanation opening. There is a this is the two pillars. This is the separation is happening. This is zone one, and also the bulging of heaving and creeping is there, and also this is a separation zone. And this is a solid zones, and also separation zones. This is a pressure arch theory explanation. So depending upon the zones, there is a P1, P2. P1 is a vertical pressure, P2 is a horizontal pressure. Once the block they open here, the vertical pressures and horizontal pressures are redistributed. So these two vertical pressure horizontal cause the new for induced stresses are developed in our the cause of AABO, EBB, CC up to CC, the bread separation, it tends to immediately come to the downwards. So it may be sometimes the bulging is going on, the creeping is going on, the heaving is also going on. So this is the experimental pressure architecture. This is the experimental pressure architecture. So the stresses are moving to the front to the like this. So this is called as the pressure arch. As soon as underground rectangular opening, as soon as a rectangular opening is made, this is the rectangular opening is made. The force in its remove supports for the immediate move. So immediate move supports are and then the results of the two events will occur. Due to this event, there is a two events are occurred. One is the immediate roof. This is the immediate roof. Uh, gradually sag into it. Gradually this is gradually sag into it. So the first effect is area is the immediate roof. That second, the leads original supports by core excavation and transferred to both sides of the open. So the pressures P1 and P2 distribution to the other areas also transfer to both sides of the open. Our abutments where the pressure become more than the average pressures. So the abutment pressure is the average pressure is more than the average pressure. That is a very essential to calculation. As a result, there is a five zones are there as per the nomenclature is 1, 2, 3, 4, 5, and five zones are there. Zones shown in figure. From zone 1 and zone 2 are distressed areas. The zone 1 and zone 2 are de-stressed areas, which are the stress relief areas. The lowest layer, zone 1, is thinner and weaker. It's tend to sag more and separate, and more and separate. Overlaying the separate is the widest between the lowest and the second lowest layer. It is gradually reduced in width until no separation occurs at the top of zone 1. This happen mainly due to the clamping action of the apartments and frictional resistance between the layer. The height of the arch, this is the arch, the overall height of the arch. Height of the arch above the opening will depending on the component layers, the uniformity in thickness and the magnitude of the horizontal pressures. Conventional floors, roof supports against immediate roof are used when the roof boards are were developed. The important advantages of are the clean and undisturbed opening with the minimum maintenance, improving the ventilation and greater freedom in missionary movement, less storage space required, and greater case in the hand. So this is the as for pressure arch theory can be how to bolting, do bolting and can be supporting can properly maintained based on the this theory. So some more phenomena are also there. The excavation is made in the strata. The pre-mining system of forces is disturbed, and the latent energy which extended in the strata. is released, and the pressure redistribution itself. The bending of roof beds will cause the bed to sag away from each other and to become detested. The deflected vertical compressive forces P will be stick and a district region along with the line of contact with ABC that is showing in the figure very clearly. So this is the here A B C D F is the separations are showing here. 1 to 3 years of George height is depending upon the excavation. So this based on this theory, the main function of the room holding is to be bed satisfied the broken rock layer together with the preventive falls. So immediate roof can be binding with the above one so that it is not falling down to the bottom of the gallery. The sag and separations. The sag and separation. The sag and separation. Uh, the sag and separation of the immediate roof are reduced or eliminated when the roof bolts are tightened and hang from the self-supporting main roof. The loading carried by the roof bolt due to the suspension can be determined easily. In many coal mines, there is a no self-supporting roof member with reservable distance above the roof line from which the roof bolts are anchored to suspend the incompetent immediate roof. The successful applications of room bolting in these areas suggested reinforcing mechanism other than suspension. And examination zone 1 figure indicates that when the roof layers sag and separate both horizontal and vertical movement occur along the bedding, when these layers are bolted uh, through, the clamping forces will be induced frictional forces along the bedding plane. The magnitude of the friction forces is proportional to the clamping forces or belt tension. The frictional forces tends to prevent further movement along the bedding planes and stabilizing the so this effect and can be interpreted in any other way. Clamping of the number of thin layers into the thicker one reduce the maximum bending strain and the clamped ends of the fixed end. The maximum bending strength for such beams is uh, it can be calculated WL square by 2 any voltage and it will the thickness of beam. It's also as the thicker than the beam it will be smaller. The maximum strain induced at the clamp ends. Uh, this is a design equation for the degree of reinforcement producer reports. The laminated equal thicknesses chart for evaluating friction effect can be used. As for the example, this graph gives the following interpretation on the rotate of the area. So that is given here. Similarly, an expression made in the strata, the pre-mining system, the forces are distributed and the latent energy instructions in the strata they release and the pressure redistribution itself. The bedding of the roof beds will cause the beds to sag away from each other and those become the distress. The deflected vertical compression force P will be split and this region along the line of contact of bed ABC. So the line of increased pressure is known as a pressure arch or pressure dome. It's called as a most of areas is called as a It's called a pressure arch or pressure dome or pressure ellipse. This is it. It's called a pressure arch or pressure dome or what do you call it? Pressure ellipse. It's called also pressure ellipse. It's called pressure ellipse or pressure dome, pressure arch. They look like an arch. That's why they call it a pressure arch. The shape of which will be largely determined by the thickness and strength of the bed. Similar distribution of the compressive forces P1 and P2 and the shearing forces S will develop in the floor, and these will tend to force the floor beds into the round roadway and cause floor lift. As the phase advances, the roof beds coverage the working places. So this is the things for the particular P1 and P2 are the vertical and horizontal forces, which is act at the particular location. The shear forces are happening in the junction. This is the S is indicated. This is here. So cause of the forces they trend is here. So this here. So most of the corners will be failing due to the vertical force versus horizontal forces causes. So that is showing you the floor, and these will be tends to force floor bed into the roadway, cause a floor lift. So sometimes due to the heavy floor cause these will be bulging. The pillars can be bulging and the floor can be heaved. The floor lift as the face advance or roof beds convergence in the working places. And so on. This overall the pressure arch theory, the conversion of pressure arch theory. Going concluding here. Overall, in this lecture, for the analysis of the stability of the underground opening, the knowledge of stresses, the strength and failure mechanism are important. So, for analysis of the stability of the underground opening, the knowledge of stresses are very important. The strength and failure of mechanisms are important. So, once you know the stresses and strength and failures of the mechanism, so that you can be, uh, analyze the underground opening. The idea of the stress concentrations and their effects, the idea of the stress concentration and their effects on the surroundings of the openings helps design engineers to plan a suitable method of supporting system. The idea of the stress concentrations and their effects on the surrounding of the opening helps the design engineers to plan a suitable method of supporting system. So, however, the knowledge of the rock mass properties are very important. There is RMR and Q system and RQD. Basically, still to be acquired rock mass classification system is an attempt towards the purpose, and also known to creep phenomena, and also time dependent. There is also a behavior of the rock, so that the strength can be weakened by due to the watery nature and time bound. The time bound character also the influence in fact for the stability of the opening. So I hope with this I'm going to conclude this today lecture. Pressure arch theory is one of the phenomena to study to decide the support systems. I hope that once opening, the vertical and the lateral pressures, how redistributed in around the opening, how to separations of the sagging and also heaving of floor. Um, these are the creeping of situations in our own opening. And also shear development, tensile where is the development opening, depending on the P1 and P2, the particular vertical pressure and horizontal pressure. Thank you.